Hello everyone, this is Yogesh. Welcome back to our channel Code Library. If you're new to our channel, then please subscribe and press the bell icon so that you will be notified first when we upload our new video. So without wasting any time, let's start our video. So today we are going to talk about another question of graph, and the question is cheapest flight within the k stops. दिस इज आवर क्वेश्चन, cheapest फ्लाइट विद इन द के स्टॉप्स. ठीक है, तो एक बार बता देता हूँ कि आज मैं इंग्लिश में बनाने जा रहा हूँ वीडियो को, मतलब एक्सप्लेनेशन इंग्लिश में दूंगा. पहले तो हिंदी में देता था, तो कमेंट करके बताना कि मतलब हिंदी में ज्यादा मजा आ रहा है कि इंग्लिश में भी मैं कर सकता हूँ. तुम लोग जैसा बोलोगे वैसा मैं करूंगा, क्योंकि हिंदी से बनाता आ रहा था. इंग्लिश में देखकर बताओ कि कैसा लग रहा है. मजा आया तो बता देना, तो इसमें भी कंटिन्यू करूंगा, वरना फिर अपन लोग हिंदी में ही करेंगे. ठीक है, चलो लेट्स स्टार्ट. So this is our question, and the question says that let's see the question. Cheapest flight within the K stops. There are n cities connected with by m flights. Each flight starts from a city U and arrives at V with a price of W. Basically, we will be given n number of cities, and there are m number of edges. What this edge signifies that we can take a flight from node number 0, basically city number 0 to city number 1. In this example I am telling city number 0 to city number 1, and the flight cost will be 100 rupees. This is our cost. The flight cost will be 100 rupees if we take a flight from 0 to 1. Like this, if we take a flight from 1 to 2, then the price will be 100. If we take a flight from 0 to 2, then our price will be 500. So like this, our cost is given. So now, given all the cities and flights, together we starting city is source and destination is DST. Basically, we will be given a starting node and also a destination node. Your task is to find the cheapest price from source to destination with up to k stops, and if there is no such route exist, then output the -1. So we will start from source node, and we have to reach the destination node, basically destination city, and we have to calculate what is the minimum cost required so that we can reach our destination from starting from the source node. Okay, and we have it's given one more condition that we have to use only up to k stops, means maximum we can use k stoppage between source and destination. So let's explore this example. In this example, it's given 0, 1 and 2. In this example, its source node is 0, basically this one, and destination is 2, basically this one. Fine. थोड़ा बड़ा कर देता हूँ. Yeah. So source is this, destination is this, and it's given that k is 1. So we have to take at most one stoppage between source and destination. So we can see that from 0 to 2, basically source is 0 and destination is 2. So from 0 to 2, we can come directly by using a single flight, and whose cost is 500. So basically this flight will take around 500. Now one more possibility is there. We can start from 0 and we can go to 1. Its cost will be 100, and then we can start from 1 and we can go to 2, and its cost will be 100. So the total cost when we follow this path will be 200, and we are using one stop. Basically between source and destination we are using only one stop, that is city number 1, and it's also not violating our condition, because our k was given we should use at most one number of stop. So we are using one stop only. So and this cost is 200, and this path cost is 500. So basically what will be our minimum path, basically minimum cost, minimum cost will be 200. Basically we are going to follow this path, right? So let's understand. This was very simple example. Let's understand some different example where we will be considering both condition, where we will be violating the k part and we are going to use the minimum distance. Let's see one more example I have drawn here. Okay, so it's given 0 to 1 its cost is 100, 1 to 2 its cost is 200, like this it's given, and our source node is 0. Okay, and our destination node is 5. So we have to go from 0 to 5, and the maximum k is 2. We are going to use maximum, means from source to destination we are going to use maximum 2 number of stoppage between them. Okay, so from 0 to 5, I think here we can see that there is two possibilities, and now it's given that it is a directed graph. Okay, because if you are going from 0 to 1, why you will go from 1 to 0 again? Because we have to go towards 5. Okay, then we can see that from 0 to 5 there are two number of possibilities. First one is we can go in this direction, and second basically 0 to 1, 1 to 2, 2 to 5, and second possibility is from 0 to 1, 1 to 3, 3 to 4, 4 to 5. Okay, then let's see what will be the total answer if we follow the above path. So answer will be 100 plus 200 plus 300, and value is 3, 4, 5, 6. So if we follow the first path, then our cost will be 600. If we follow the second path, what will be cost? 100 plus 100 plus 50 plus 10. What it means? 100 plus 100, 200, 250, 260. So if we follow the below path, it will cost us 260. So we can see that if we follow the below path, it is cheaper, and we have to calculate the minimum cost only from starting from source, and we have to reach the destination, and we have to use the shortest path, basically cheapest path. So we can see that the below one is cheapest because its cost is 260, and for the first path its cost is 600, and it is, I think, it's more expensive than below one. So are we going to take the below one? Let's check one more condition, this k condition. We have to check two conditions. First, we have to check whether we are using only k number of stoppage between source to destination, and we are using a cheapest path. Okay? So we can see that cheapest path is below 1, but let's see if it's violating the kth condition or not. So k is given 2, we can use only maximum 2 number of stoppage between source and destination. But if we follow this path, we can see that we are using 3 number of stoppage, 1, 3 and 4. Between 0 and 5 we are using 3 number of stoppage, 1, 3 and 5, 1, 3 and 4. It means that it is violating our k condition. So we cannot use the below path because here we are using 3 number of stoppage, and it's given that we can use maximum 2 number of stoppage. So we cannot follow the below path. Then we have to follow the above path, and our final answer will be 600 and not 260. And now let's check whether above path is following our condition or not. Yeah, in the above path we can see that only we are using 2 number of stoppage, and this is our, and it's also satisfying our condition also, because k is given 2 and this is also 2. Basically we have to use 2 or less than 2. Okay? We cannot use more than 2. So above one is satisfying our condition, so we are going to take the above one only. So I think you understand the concept that we have to check the minimum cost also, and we have to check this k condition also. So let's see how we are going to solve this question. I will be iterating in this example only. So let's see. So first of all, our first condition is that we have to calculate the cheapest path. We have to take the cheapest path. So what I will going to take, I will be taking a priority queue. Fine. And in priority queue, I will be storing in a tuple form. Basically, what is tuple? We are going to store three elements together. Okay, like we have used in pair, there we use only 2 elements, and in tuple we use 3 elements. We store 3 elements together. So I will be using a tuple, and I will be using a priority queue. In priority queue, I will be storing all the tuples. So why and now I will be taking the mean heap priority queue, because we have to calculate the cost, and that will be minimum. So what is mean heap priority queue? Basically the top element of priority queue will return the minimum value of all the elements of the priority queue. सबसे जो मिनिमम होने वाला होगा, जो सबसे मिनिमम हो रहा होगा प्रायोरिटी क्यू में, वो हमारा रिटर्न होता है इफ वी टेक द मीन हीप. So we are going to take a tuple. So what are the things we are going to store in tuple? First value of tuple will be our cost. We will be going to store cost, and second part will be our node, basically city number, in which city we are, city number 0, city number 1, city number 3, in which city we are going to store the city number. And third will be our k, basically this is stops, how many stops we are taking, basically stops. Okay, so these are the 3 parameters of our tuple, and we are going to push this in our priority queue. So how we are going to solve, let's see. First I am going to take a priority queue, and first I am going to push our source node. Basically we are going to start from source. So what I will going to store, when I am in this source node, then our cost, what is our cost? It's 0, because we have not traveled anywhere. We are starting from the source node only, so we have not traveled anywhere, so cost is 0. In which city number we are in city number 0, so it will be 0. And then what are the total number of stops we have used, means the middle stops. We have until now we have not traveled anywhere, so we have not used any number of stops, so our stops is also 0. So this is our first tuple which we are going to insert in our priority queue, and priority queue basically PQ, priority queue, and this is our mean heap. I have told why I have taken mean heap, because we have to calculate the minimum distance. So I think mean heap will be beneficial for us. So and as I am storing in a tuple and the first element is cost, so basically in priority queue the the tuple will be stored in the on the basis of cost, whose cost will be minimum, that will be in the front of the priority queue. That is our basically the mechanism of mean heap. Okay, so first of all we are starting from source, and this is our first tuple which we have inserted in our priority queue. Then we are going to pop this, and we are going to explore this element. Basically we are going to, first of all we will be checking if our this node, basically this city number, if this city is equal to destination, it means that we have reached our destination node. Then simply we are going to return this cost. तो ये सब बाद में बताते हैं, पहले थोड़ा एक्सप्लोर करके बताते हैं, तब ज्यादा समझ आएगा. ठीक है, तो या लेट्स एक्सप्लोर दिस सिटी. सो फ्रॉम दिस सिटी वी कैन गो टू सिटी नंबर 1. So what we are going to insert in our priority queue, basically this distance. What is the distance between 0 and 100? So our distance is incremented from 0 to 100. Now our new city is 1, and this is our one of our stoppage. So we have used stop 1. We are using one stop. Okay, so this is our new tuple which we are going to insert in priority queue. So we have explored this one, so we are removing this from our priority queue. Now inside our priority queue we have having only one tuple. Fine. So we are going to explore this city 1. So basically from 1 we can go to 2, and we can also go to 3. So we can explore both of them. So first we are going to explore 3. So if we come from 1 to 3, what will be our total cost? Previous cost was 100, and between 1 and 3 the cost is 100, so total cost will become 200. And now new node is 3, and we are using 2 number of k, basically 2 number of stops. So we are incrementing stop with 2, because already we have used one stop, and now we are coming to 3. So now the total stops become 2. Basically we are using one more stop. Okay, now we are exploring this part. So what will be this part? Till now 1, our answer is 100. Now we are going to 2, so our cost will become 300. 100 plus 200, 300. Node number is 2, and our k is 2. Total number of stoppage 1 and 2. These are the 2 number of stoppage. Now this we have explored, and now we are removing it from the priority queue. Now we are in node number 2, and we are in node number 3. Now what should I explore first? ऑब्वियस सा बात है, हम लोग उसी को एक्सप्लोर करेंगे जिसका कॉस्ट मिनिमम हो रहा होगा. So we can see that in node number 3 our from source node we have reached to node number 3, and our cost is 200, and from source node we have reached to node number 2, and our cost is 300. So basically we are going to explore this one because its cost is lesser than this one, and in priority queue we are using mean heap. So in the front of the priority queue we will be getting this one. Fine. So let's explore from 3. So from 3 we are going to 4. So what will be our cost? 200 plus 550. It will increment to 250. Okay, and we are going to node number 4, and now we are using one more stop. So our cost stop will become 3. Fine, and we have explored this. So let's remove it now. And now let's see which is minimum among this. Now we are here, and now we are here. Okay, let's remove the, because we have already explored this. Now we are in node number 2 and node number 4, which is minimum again. This is 250, this is 300. Again 250 is minimum, and it is lesser than 300. So we are going to explore node number 4. When we started exploring node number 4, first of all we will check whether this k is less than equal to 2 or not. If it is less than equals to 2, then it's confirmed that till now we have not used all the k stoppage which is allowed. But now what we can see that the value is 3. Basically this 3 is greater than k, and our k is 2, and now it's showing 3. Our 3 is greater than k. What does it means? It means that we have used more than k stoppage. But what was the restriction given to us? We can use at most k number of stops, but we are using more than k. If we are going to explore from 4, then it is clear that we have explored we have used 3 number of stoppage, but we cannot use 3 number of stoppage because it's written that we can use only 2. So it's simply we are going to remove this from our priority queue and we will go back. Basically, we are not going to explore further from node number 4 because we know that this path is wrong because it's using more than k number of stoppage and we cannot use that. Fine. So we are simply we will remove this from the priority queue and we are not going to further explore this. Now let's see what is the remaining element in priority queue. So we can see that now in priority queue it's 3 and 2, node number 2. We are in node number 2 and its value is 300. Now let's explore this. We can explore this and we can go from 2 to 5. Now its value will become 600. We came to node number 5 and we are using k will become 3. Fine. And we are going to remove this one. Fine. Now we now again we will take the front of the priority queue and now again only one tuple is there in priority queue. Now we can see that what I told, one more condition I am going to check whether this node is equal to destination or not. If it is equal to destination, then we are not going to check whether k is greater than or not. First condition will be we are going to check whether this node is equal to destination. If node is equal to destination, if this condition doesn't pass, then we are going to check whether our stop is greater than k. If it is greater than k, then we are going to simply continue because we are not going to explore any further. If this also fails, then we are going to explore this node. And now in this we can see that this 5 is equal to destination. It means that we have reached to the destination node by using our k, which is means basically 2 number of k we are using. Okay, so and we can see that its k is 3. It means that we are now in third position, but that is our destination only, so we cannot say that this is our extra stoppage. Okay, so here we have used 2 number of stoppage only, so we can see that we have reached to the final destination, so we will return this. This is our cost and we can see that 600 is only our answer. So I think you've understood the intuition. Let's see the solution, how we can do. Solution is also very simple. ठीक है, तो मजा आ रहा है ना समझने में? चलो आगे समझते हैं. So it's given that n basically number of nodes. We have given the flights basically u to v and weight. Basically we will given the 2 nodes from node number u to node number v and the weight is w. This is given this flight. Source node, destination node and k, which was the restriction that we can use only k number of stops. Now we are going to make a graph, vector basically agency list, and we are using pair only because we are going to store from u node we are visiting v node and the weight is w. Like this we are going to store. That's why we have taken vector pair. Now in this flight we are iterating auto x flight and we are basically we are making a graph of x of 0 dot pushback, x of 1 comma x of 2. Basically x of 0 is the node number u and x of 1 is node number v. From u to v we are going and the weight is x of 2. Simply we are storing this. Now we have taken a priority queue and basically in tuple format. So tuple int comma vector tuple int comma greater tuple int. So we are writing greater so that it will be a min heap. So this is a min heap priority queue and its variable is pq. pq dot push make tuple 0 source and 0. What is this 0? Initial cost is 0. We are starting from source node and this 0 is what? The total number of stoppage which we are going to use. Until now we have not used any stoppage, so 0 source 0. Now while loop not pq.empty, cost u and stops we are pq.top. So basically this is our auto operator. We are pq.top. So what we are getting? A tuple. So in cost we are getting this 0. In u we are getting this source and this stops we are getting this 0. So this is our auto operator. We are storing all these 3 elements from this pq.top. Now we are popping this element from the priority queue. Now we are checking first whether this u is double equal to destination. If it's double equal to destination, then we are returning this cost as I told in you intuition. Then we are checking if this stops is greater than k, then we are continuing. It means that we are going to use more than k number of stops, which is not our condition. Basically it is violating our condition. So we are not going to tolerate this and now we are going to continue. Basically we are not going to explore anymore. Now if this both condition fails, it means that we are going to explore that node and that auto child graph of u. In again we are using auto operator u comma w equal to child. Basically from child we are getting 2 elements. This u is our node and this w is our weight between u to v. Now we are going to push in our priority queue make tuple cost plus w. What was our previous cost? it was stored in the cost variable, and now current cost between u to v is w. Now we are adding this. Current node is v. We are going to vth node, so we have written v, and we are incrementing the stops. So we are incrementing stops plus 1. Like this whole while loop will run, and we will get, if we get to the destination, simply we will return with this value cost. And if this whole while loop run and if we doesn't get any answer, basically if we not able to reach our destination node by using maximum k number of stops, simply are going to return -1. That's all. Let's submit this solution and the answer will be correct. We can see that the answer is correct. We can see that it was success, faster than 88%. So let's talk about time and space complexity. So for time complexity, we are using v plus e log n. Why? Because see that we are running only, we are exploring all the nodes, and in all the nodes we are exploring all its adjacent. Okay, so this while loop is we are running in this for loop. We are using push operation of priority queue. So basically in priority queue, when we are pushing something, then it will take log n operation, and basically like BFS only we are doing. We are getting one node, and in this for loop we are exploring that node, and here we are doing in log n operation, basically pushing the elements, basically tuple in the priority queue. So this time complexity will be v plus e log n. And if we talk about space complexity, the space complexity will be order of n, because we are making a priority queue, and in priority queue we are inserting all the nodes. At least all nodes will be inserted once, and so its space is order of n. And we are not considering the space of this input vector, because this vector was already given to us, so I'm not considering this space. I am considering only priority queue space. So and the solution is also correct. So hope you understood the solution. If you're new to our channel, then please subscribe, and if you like the video, then अब हिंदी में आ जाते हैं, तो यार वीडियो मजा आया तो लाइक मार देना, और बताना कमेंट करके कि यार इंग्लिश में कैसा लगा, समझ कर मजा आया तो नेक्स्ट टाइम इंग्लिश में बनाऊंगा, वरना फिर अपन लोग हिंदी में ही समझने लगेंगे। ठीक है, वीडियो पसंद आई है तो यार लाइक मारो, सब्सक्राइब करो, ग्रो कराओ यार, तब तो मोटिवेशन आएगा। ग्रो कराओ चैनल को, सब्सक्राइब करो। चलो मिलते हैं नेक्स्ट वीडियो में, तब तक के लिए